Hello, my name is Tayo Ogundele, and this is my Physics 2 Lab 1 charge tapes. Intro, the purpose of this lab is to become familiar with the idea of charge, which is a property of matter that household objects and everyday objects have. The fundamental physics principles that we use in this lab is going to be Newton's second law, which is F equals ma, and we'll use that to calculate the total force on the tapes, and Coulomb's law, which we'll use to furthermore get the charge on the tape. A little preview of the main result. So we got the charged piece of tape is equal to 9.41 e to the negative 9. And then for the ratio of atoms that ended up giving up an electron, it is approximately 1 in about every 6.6 million atoms lost an electron. So some assumptions we made during this lab are that the tapes will act as point charges, and that each tape will have the same charge, and also that 1 gram of tape is equal to 1 meter of tape. So the procedure, we placed a base tape on a table. You then fold a little piece of the tape to create a non-stick handle. You lay that down onto the base tape. Then you quickly rip that off and place it onto floating stackable objects. Then you're going to want to do this again, so create another non-stick handle, place it on the base tape again, rip it off to charge that tape, and then you're going to hold it under the other charged tape on top of the 2 stackable objects until that first piece of tape starts to float. And so for system and surroundings, the system is tape B in the diagram to the bottom right of this slide, and the surroundings is tape A. And so for initial conditions, the length of my tape was about 8 inches, which is 0.2032 meters, and the mass, which again we're using the assumption that 1 gram of tape is equal to 1 meter of tape, and this mass is in kilograms. It's 2.032 e to the negative 4, and then the distance was 2 centimeters, which is 0.02 meters. And so for my computational model, I made this code, which it shows the particle is the bottom piece of tape, and then the observation location is the system, which is the top piece of tape. And then at the bottom you can see the calculations. You calculate gravity, and then down at the bottom, this Q equals the square root of gravity times distance squared divided by K, which is our constant for our Coulombic constant. And this was basically derived. You just do some algebra on a F net equation, which is Newton's second law, to be able to find what Q is. Some possible errors: discharging the tape during handling. If you weren't careful, you would touch the tape too much and it would no longer be charged. Also, creating the tapes manually causes some inconsistency. Sometimes you might rip off more electrons or lose more electrons than you intended, or lose more electrons than the first piece of tape, so one might be more charged than the other. And then just time for tape to discharge, because while you had it floating between the stackable objects, it would often discharge if you took too long making your second piece of tape. And then what if question: what if electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tape and other objects? Tapes would still attract neutral objects. They would repel positively charged objects, and vice versa. They would attract negatively charged objects. But they would still repel each other, so the observations made during the actual experiment probably wouldn't change much, because they would still be the same charge, so they would repel each other. And then why? Why is it important to handle the charged tapes as little as possible? And what happens when the charged tape comes in contact with your hand? And so we kind of talked about that during errors. It's important to handle them as little as possible, because you could discharge the tape with your hand if you're touching it too much. And so what actually happens when you come in contact with the tape is basically the tape is taking electrons from your hand, and to neutralize its net charge.